Hello, Geoff here, co-host of the pod, here to tell you that, once again, my audio kind of sucks. This stems from the same issue that impacted our last episode. Thankfully, this is the last episode where we should have bad audio. I'm really sorry for the poor quality. Luckily, I don't speak nearly as much today, and Hunter, who does, sounds great. We return next week with a super fun episode on the geography of Lego, and I assure you, I will sound much better. So enjoy today's episode.
Geoff, if you had to guess, what would you say the amount of wind energy generated for electricity worldwide is? What percentage do you think that might be?
Worldwide? So like you're talking about Europe, United States, Asia.
Yeah, the whole planet, everywhere in the world.
And
then we could look at the United States too, but let's look at the globe.
We'll start global. We'll start up here and we'll work our way down.
Yep.
Geez, I don't know off the top of my head. I would guess it's probably something laughably small, like 1% or something like that. That would be a real. I mean, I'm just thinking. The way I'm thinking about this is that I'm thinking of wind energy, and I'll back up my arguments here. I'm thinking of wind energy as largely being a technology that's used probably by more wealthy nations, more wealthy countries. And so when I start to think about that, I actually start to think about, okay, what are those countries? Well, United States, Canada, probably China, Japan, Korea, most of Western Europe. And then I start to think of, okay, which one of those would actually be using it that I've heard about using it. So I'm probably going to have that population.
Okay.
And so I'm going to start building down to like a very small amount of a percentage when it's like only like a small percentage of the US and Europe is using it and all this kind of stuff. How wrong am I?
I guess the good news is that it's higher than 1%.
Okay.
Bad news, it's not a lot higher than 1%. So the statistics I have suggest that for worldwide electricity generation, that 5.3% worldwide comes from wind power.
That's way more than I would have expected, actually. I'm actually pretty impressed by that.
This compares to 63% for fossil fuels, which gets divided up. Coal and gas, each about 37%, oil 3.1%, hydropower globally almost 16%, nuclear, and this is, if anybody hasn't listened to it, you should go back and listen to the nuclear episode after you listen to this one. That's 10%. Solar 2.7%, so much less than wind. And then all the other renewables together 2.5.
I would have expected solar to be higher than wind. And the reason why, maybe we'll get to this in the episode, the reason why is because I guess when I see wind energy turbines versus solar panels, I kind of assume that solar panels would be a lot more consistent in the energy they can deliver, right? Because when the sun's going to be up, you can sort of math out sort of the angle to get maximum exposure. Whereas I feel like the wind energy can be a little bit more variable.
Well, they both wind and solar have variables attached to them, and that's one of the reasons. And we'll probably come back to this at the end, that many people propose that if used in tandem, if used in conjunction, they can be really effective, and we'll talk about that. But in terms of worldwide total energy, so that is electricity, transportation, and heat. So that's a larger category. Mm-hmm. The percentage does go down to 2.2%. So for electricity, it's higher, but for all total energy, and fossil fuels is 85% or 84% at that point. Solar only 1.1%, hydropower 6.4%, nuclear 4.3%. So that's a different look at things. If we look at U.S. power generation, and we're looking at electricity, strictly speaking, wind is 9.2%, so higher than the world average overall, which goes with maybe some of the things you were thinking.
Yeah, I guess so. Yeah. Just a wealthier nation, a lot more capital. Right. I also know, like, for example, the U.S. has the Great Plains, which I think is generally considered to be a pretty windy area of the country. Yep. I don't know that specifically. I just, based on sort of my knowledge of it.
That's correct.
I think it would be more amenable to wind energy, but I really don't know.
Well, we will talk about the geography of where wind power dominates in the United States and in the world. Mm-hmm. This episode is dedicated to wind power. But before we get into some of those aspects of things, another historical geographical thing we could talk about is the history, a little bit of history.
Let's do it.
And wind power has been used by people for as long as sails have been put on boats, really. If you think about it, that's one way of harnessing wind power that has been used throughout the world and it continues to be used. And of course, we're talking about wind as energy production, so it's a little bit different. But, you want to acknowledge one of the ways in which wind power has been harnessed by people. And then windmills have been turning wind into power for thousands of years in different places as well. And so what's interesting, because we're going to be talking about some of these, just briefly, some of these way back examples that go back thousands of years, but the modern industry of wind power is actually maybe 40 years old or something like that. So although there's a rich and long history of using wind power, using it to generate a lot of electricity for a grid or something like that is more new, relatively new. Windmills have been very instrumental in moving water for various reasons, especially for agriculture, for irrigation and things like that. So that's one of the main ways in which wind power is harnessed to move water around. If you think back to the kingdom of Hammurabi in Babylon,
wow, that's a long time ago. Yeah,
that's 3,700 years ago. Apparently, Babylonian cities were using windmills for irrigation that long ago. So that's one of the earlier examples that I saw. Wind power was harnessed for various reasons in ancient China, Tibet, and Greece. In Sri Lanka, wind was used to power furnaces about 2,000 years ago. As far back as 200 BCE, windmills were used to mill grains in Persia. So we're hitting on different parts of the world here. Windmills were built in the 7th century Afghanistan to mill grains. In the 9th century, and we mentioned Persia, Iran, and Afghanistan, and then Pakistan as well. So we a number of places in Central Asia. And then some people, when they think of windmills, their minds might go to images of the Netherlands, because that's still
I was going to say
part of the landscape today.
That's my first reaction when somebody says windmill, especially in historic context, is I can see that building, right? Sort of like a triangle shaped building. It sort of like curves up towards the end, and then there's just these big sail things that sort of move around. And I was actually in one the last time I was in, a time ago that was in the Netherlands. I got to do a little tour inside one, and you could actually see it moving, and then going through the whole grain process of crushing the grain. Right? I don't know what it was doing with the grain, but there was grains involved.
So in the Netherlands, many people, even if you've not been to the Netherlands, it might come to your mind because it's used in art and it's replicated. It's a really important part of the culture and the landscape. But windmills were used in the Netherlands to drain polders, and polders are the low-level land that's created by pumping water out and then securing it with dikes. And so that's been happening for hundreds and hundreds of years in the Netherlands, and also to grind grain, to mill grain as well. Mm-hmm. And so we're looking at, as early as 1200 Common Era. So, a long time ago, right?
Yeah. So that's still, it's like 800 plus years ago?
900 years ago, something like that. Yeah. So pumping water, if we want to get a little bit more contemporary, in the Midwest of the United States and in the Australian outback, for example, were really important for farmers, and particularly in North America. Wind power is used to, again, move water around, right? To draw water from wells and for irrigation. In a lot of places that weren't connected to anything else, wind power is a place that this was done. Another thing you might not be thinking of automatically, a use in the early industrial period for wind power, was to pump water for wells in order that they'd be available for steam locomotives.
Oh,
so steam locomotives need water, right? And in fact, every 7 to 10 miles on early train lines, there would be a huge water tank that the train would draw that back. And so, wind power in this way, as it relates to water and then steam technology, figured in the early spread of railroads.
That's so interesting, because I guess when I think about the old steam railroads, I think it's like heavily coal dependent, which is like sort of wrapping.
Also true.
Starts wrapping in the Industrial Revolution and sort of like all of the, I guess, maybe the beginnings of really the mass use of fossil fuels to power things. And so I guess I would just kind of assume that at that point, anything and everything that they needed to power anything and everything, they were going to gravitate towards this newfound sort of use of coal to then do. So I'm kind of surprised that
water still figures prominently in the history of steam locomotion.
Yeah, and that it was wind energy that was used to pull it together, a renewable source, quote unquote.
So there were a couple individuals in the 1800s, the late 1800s, that were pretty forward looking and had devised independently of one another ways in which to harness wind power to create electricity, right? Which is kind of the main theme of what we're talking about.
Right, because up to this point, it's all been very sort of like the wind power is just doing one very specific thing. It's not really providing electricity. So
right. I mean, it's the power is being used, things that we would use electricity for today,
right.
But they're used to power a mill or to drain water or to move water around for irrigation, something like that. So we have in Scotland, James Blythe, I'm not sure how it's pronounced, who is producing electric power back in 1887, created a device to do this that powered the lighting in his cottage. And he generated enough power. And the story goes, and I read this in a couple places, that he offered the surplus electricity generated from his wind operation to the people of Marykirk, which is where he lived, for lighting the main street. And the offer was turned down by the villagers who thought that electricity was the work of the devil.
Which is funny to think about now, but like obviously back then,
right?
There's that famous quote. It's like anything that is sufficiently advanced enough so that you can't comprehend it, it might as well be magic or something like that.
That's right.
And so these people were probably thinking like, oh, this is witchcraft.
Well, and I think that's exactly what people were thinking, that this was some kind of wizard or something like that. But what's not that dissimilar from today is that I think a lot of people would say wind power really to generate a lot of electricity, that really can't be viable. So I mean, the reluctance to adopt wind power has not necessarily disappeared, although certainly there have been a lot of improvements since the people of Marykirk established it to be just straight up work from the devil. So
yeah, perhaps that's very true. I mean, going back to sort of the first question you asked me, which was how much energy is generated worldwide, and you said 5% globally. That might seem like a small number just relative to everybody else, but that's still multiple gigawatts of energy to power hundreds of thousands, millions of homes around the world and businesses and all these other things, right? That's a significant achievement and a significant amount of electricity that's purely being generated just by wind and these
absolutely
other things that go with that, right? That I think we're going to get to in a little bit.
So around the same time, 1887, 1888, but this time in the United States, more specifically Cleveland, Ohio, we have Charles F. Brush, who built a very large machine for generating electricity from wind and used it to power his electricity for years and years without any kind of interruption or anything like that. So these individuals who are wanting to harness power for electricity, which the technologies are still developing. But it's really, if we jump ahead, that the modern wind power industry, which we'll be talking a lot about today, really only dates back to the late 1970s. And it was catalyzed by wind power developments and innovations in the country of Denmark. But also the context here, and I know you don't remember the 70s because you weren't around for the 1970s, but I can tell you that there was, and you may have learned that there was an oil crisis in the 1970s.
I have heard of the oil crisis. Oh,
that's right. So you know about this. And so there was a lot more political will and public interest in developing wind energy as an alternative energy source during this time. So the 1970s is part of that. On average, since 2005, 3,000 turbines have been installed annually in the United States. So
that's pretty impressive.
There's been an increase.
And I've seen one of those bad boys drive by, at least just one of the blades
yes.
on one of those bad boys drive by me on the highway. And like you see them off in the distance and you think like, well, you probably already think they're pretty big, but they're a lot bigger than you think.
They are massive. They are really big. And we're going to jump into just how big they are here in this next section. One piece of clarification, and this is kind of an interesting thing, that turbines that are grouped together in one location are called wind farms.
Well, that makes sense because it's renewable.
Right, because they're harvesting, I guess they're harvesting wind, yeah. Right? And they're grouped together. Yeah. And sometimes they're established in actual farms, right? So you might see some agricultural lands, as you said, in the middle of the United States, for example, where it's conducive to building these turbines and capturing wind power, and they might be among agriculture. So just in a real basic way, because that's the only way that I understand this, how wind turbines work, the wind blows the aerodynamic blades, and in most cases, it's 3 blades, right? That
I think
capture
it was
the
one I've
wind,
seen,
right? The blades are often made of fiberglass. They vary in length. One of the standard varieties of blades is 116 feet long. Another one is 170 feet long. The average height of one of these turbines onshore is 466 feet, but they can go up to 574 feet. So the higher up you are, the more that you're capturing more consistent wind.
If we can track back really quick to our episode on skyscrapers.
Yes.
Skyscraper is like defined at, I think it was 492 feet.
Right.
So I guess the average one is 466 feet, almost a skyscraper, but some of them well over a skyscraper.
Many of them are skyscraper in height. And in fact, the largest ones are the ones that are offshore. And we're going to talk about the offshore and onshore distinctions as well.
Right.
But there's one of the newer models is the GE Halliday X offshore turbine, which is 853 feet tall.
Wow.
Which is 2.7 times the height of the Statue of Liberty.
Wow. Wait, are those installed? Sorry, did you say those are the ones that are offshore?
That's offshore, right.
Do those account for, I guess when I'm thinking like something that would be offshore, there's a certain amount that's going to be
right. I'm not. That's a great question.
Yeah.
My sense is that's the height above water, but it could be that that's the height, including the foundation.
Yeah.
But I'm not completely sure about that. The other thing is that they also innovated a technology where they have some offshore turbines that are floating on some kind of device or something.
Oh, interesting.
That's not been widely adopted yet, but the idea is that you'd be able to access deeper waters, and there's a lot of construction that wouldn't have to happen. So that's something that seems to be developing.
Well, and also I imagine if you're able to like have a floating platform in the middle of, let's say, the Pacific Ocean, far away from any landmass, you're going to have winds of greater velocity because you're not going to necessarily need to account for things like a mountain or a city sort of stopping wind and slowing everything down. Maybe that's something that could generate a lot more power.
There are some big advantages to being out in the open ocean. And there is a lot more energy that can be created on the offshore, by offshore turbines. However, at the moment, it's easier to put them on land. And currently some 90% of wind energy production happens onshore. And I think that's going to be changing over time. It'll probably be more and more offshore, but at the moment, the vast majority is onshore. So those blades, getting to the offshore blades, some of those blades themselves for the largest turbines are 351 feet long. So that's a single blade the size that's longer than a football field, if we want to measure.
Yeah, that's a single blade. That's, again, I'm at 351 feet, just going back to my skyscraper analogy. It's not quite a skyscraper, but it's getting close.
That's right.
It's closer to skyscraper than not skyscraper.
It's massive. And so the motors, the blades are involved in turning motors, and there are motors that will actually in turn face the blades to accommodate the change in wind direction, so they can achieve optimum orientation this way. The wings are attached to a gearbox, which increases the speed. And then the gearboxes are in turn attached to generators, which generate the electricity. The electricity produced is then transferred through wires to a transformer, usually at the base of the turbine. And then it's connected to some kind of electrical grid. And then the turbines also have brakes for when speeds become too great for the machine to handle. So these are some of the basic components of a wind turbine system.
So this would be like there's too much wind, it's blowing too hard, which could fry out the generator. Probably in very layman's terms.
Right. So to be able to regulate that, because you want a certain speed, but you don't want it to. I've seen footage online of a turbine that was spinning too fast and collapsed.
And it just sort of destroyed itself.
Horrifying, right? Yeah.
Yeah.
I don't think this happens a lot. I don't mean to start this way, but of course, any technology can break down, and that's a possibility. I think it's somewhat uncommon, but it's something that can happen. So there's a lot more to say, but maybe this is a good time for us to take an ad break and then come back and talk about offshore, onshore, and some positive aspects, and then some of the negative aspects associated with this technology.
All right, let's do it. We'll be right back.
And we're back talking about geography is wind power. We're talking about how to generate electricity through wind power, and we're starting to get into some of the benefits for that as well. Now, according to the U.S. Geological Survey, the average wind turbine that came online in 2020 generates enough electricity in just 46 minutes to power an average U.S. home for a month.
Wow. Okay.
Right. So, I mean,
impressive.
that's sort of helpful, but it's kind of hard to crunch the numbers and understand that. But
it's like, obviously you wouldn't like be able to store that, like, because like there's all this
storing is complicated, right? So storing involves the innovation of batteries that it becomes a little bit more complicated and a little bit more tricky. The best way for this to function is to deliver the energy as it's created, which, you know, can be variable. But let's get to that in a moment. I want to talk a little bit more about the difference between offshore and onshore.
Okay.
The offshore facilities the onshore facilities tend to be a little bit more controversial in some ways, because eventually it's going to have this huge impact on the landscape. And not everybody wants that, right? And so even though it's a really good, and it's easy to say if you don't have one nearby, in the same thing with cell phone towers, right? Like we want to use the technology, but if it happens to be, you know, in your field of view, that's not necessarily favorable.
Yeah,
they
so
also
sort of
make
like visual pollution almost.
Visual
right?
pollution. There also is a noise component as well. So it's not screamingly loud, but you know, sometimes in your kitchen, you can hear the refrigerator running.
Yeah.
That's the kind of situation you might have if you live near a wind turbine and you're always hearing that. So you can understand how people might be in favor of the technology, but then having it really close to where you live might not be favorable in some ways. Let's see, the offshore facilities are much more expensive to construct and to maintain. So even though there's a potential to gain more power from them, there's more cost involved as well. I mentioned the floating wind turbines, which allow more flexibility. That's still, I think, largely being developed. The Biden administration has been pushing for more offshore wind farms. And I'll mention now, and we'll mention again later, that there are 2 main offshore wind farms in the United States. Almost everything is onshore in the United States.
I think the one that I'm thinking of is off the Cape Cod. I remember reading about some sort of issue. And I remember, and maybe it's just because I wasn't there, because pictures can distort things. But I remember seeing a picture, and it's like you could barely see them on the horizon. I was like, what are people getting upset about?
Well, I mean, it's much more complicated in the United States from a legal standpoint to get approval to do that, because there's all kinds of governmental agencies. And then there's the fishing industry as well, which is very concerned with what impact this might have on fish stocks and also the safety for navigation that happens. So those are some of the complications that come up with these, in addition to being able to stomach the fairly large cost of getting these things going.
Totally.
So what are the advantages? What are the positive aspects? Geoff, what would you say some of the positive aspects of wind power?
Oh, I would say, so I mean, I'm going to take the easy one, low hanging fruit here. But in an age of climate change, this is a generation of power that at least has comparatively very minimal impacts, you know, as compared to things like coal or natural gas in terms of putting things out into the atmosphere.
That's right. Right. So there's two sides to that. One is that wind is a renewable energy source, right? I mean, unless things go totally wrong, we're not going to run out of wind, even though the regime of wind might be different from place to place and time to time. So it's a renewable resource, which fossil fuels are not. And there are much fewer environmental impacts involved with wind energy compared to many other forms of energy generation.
Right. And that's not to say that like the creation of these things, right? Everything that goes into making the blades, the structure. Right. There's a pollution impact to that as well. And I think we
for sure there is
extensively in some of our other episodes. Right. There's always that impact. But I think when you look at it in the long term as compared to something like coal, it's probably a fraction of a fraction in terms of the overall sort of output of pollutants into the air.
Right. And the idea is once a turbine is created, it's not generating emissions.
Right.
Now there are some, there is lubricants that are used in the machines, and those probably have to be disposed of and things like that. But in terms of just its functioning, it doesn't release emissions in the way that burning fossil fuels does, for example.
Right.
It does not require water for cooling. So this would bring us back to the nuclear energy situation where, that's a consideration, and water is precious. And so that this is a technology that doesn't need additional water for cooling or anything is something that's important.
I have a quick note on that because it's kind of similar. And so a while ago, I did a video on solar power, and I'm sure we'll cover solar at some point as well.
For sure.
It's a fascinating topic itself. And I do recall one of the, I would say, environmental impacts that people probably don't think about with respect to solar is actually how much water is needed. Because especially if you put these things out in a place like a desert, which you would assume would be the ideal place, a lot of sun hitting these things, you end up needing to use a lot of water to just wash off the dust in order to keep up that efficiency.
Interesting.
So it's kind of this interesting idea that things that you maybe don't think needs a lot of water actually ends up using quite a bit of water. So it's actually kind of nice to hear that wind energy doesn't really use it.
That's right.
Really use it.
And that's maybe another advantage that it has over solar. The price of wind power is generally more stable than the prices of fossil fuels. So that's a more consistent sort of price that you can expect. We've seen certainly in the current era right now that fossil fuel prices can increase dramatically very quickly. And why they do is not always clear. But the idea is that wind power might be able to generate wind power that is got a more stable sort of price of attached to it. And that's an advantage. And then the energy return on energy invested. So the energy payback time is about a year, generally speaking. So for the point that you start to get a net energy gain from creating these things takes about a year.
So if you were to quantify the amount of energy that goes into making the blades and the posts and foundations and everything, it takes 1 year from that sort of thing operational before it pays itself back, and now it's a net.
That's correct.
Okay,
that's right.
Yeah. Cool. Yeah. That doesn't seem like that long at all. Do we know?
No, I mean, it strikes me as considering that most of these can run for approximately 20 years plus, and I think that's probably getting better and better. That's kind of the lifespan of the blades themselves, and we'll revisit that in a few moments as well. We need to talk about the fact that there's not only positive aspects, there's some challenges and negative aspects as well. And one of the things you've already highlighted, which is that wind power is variable, and on an hourly basis, daily, seasonally, annually, it's not predictable, right? And so that's a challenge for sure.
Right. Which I'm assuming, maybe that's why offshore is going to become more important and more part of the bigger picture of wind energy, is because, again, I'm not an atmospheric scientist, but I generally would assume that there's probably more consistent winds out in the ocean than there is on land, for just the obvious reason that there's things here that stop wind,
stuff in the way, right?
Yeah.
So I think that that's generally the case. Not universally true, but that's the reason why there is looking at offshore more and more for that very reason. These things do take up some space, right? And so not that other forms of energy production don't, but wind is one of those. So you have to space the turbines. You have to create access roads for the ones on land, transmission lines. So all that takes space. However, as we've already commented, the spaces in between can still be used for other things, including agriculture. Some of the issues might be, and this is true of really any kind of energy generation, is jeopardizing heritage sites for indigenous people. And so, the exact geography of where they are is extremely important as well. So that's something to keep in mind.
Yeah, especially because as we're talking about where some of these would be, I mentioned the Great Plains states, which is obviously hugely impactful for a lot of different historical sites and heritage sites and, indigenous people sites. I absolutely could see something like this running into those kinds of issues often.
That's right. We've talked about a negative thing for a lot of people, for some people, is the visual impact on the landscape, that for people who live or work near wind farms, it's not necessarily favorable. And there's been some people who have written about how that there can be a negative impact on tourism associated with this if people are looking for particular views. However, I've also read that at least one wind farm has, and I think this is in the UK, has attracted tourists, right? So that, I guess, can cut both ways a little bit.
Yeah.
Another thing that to think about is that the turbines may have some impacts on different species of animals, right? So the noise that it makes may have an impact, not just on people, but various species of animals, may result in habitat loss, habitat fragmentation. And then there are a couple animals in particular that have been found to be very susceptible, which are birds and bats. So birds and bats can be injured or killed if hit by turbine blades. And by one estimate, by the USGS, tens to hundreds of thousands of bats die from wind turbines annually in North America alone every year. Bats are important unto themselves because they're a species. They're also pollinators, right? Mm-hmm. And so there's all kinds of things that we can think about there. About 3/4 of these bat fatalities are from tree bats that migrate long distances in the late summer, early fall, which corresponds when most of these fatalities are happening. So the migrations are becoming interrupted. So there's, the decline of some of these species. Also offshore turbines, and I think the research is still kind of developing here, maybe impacting animals, including sea turtles, migratory birds. And, having said all that, the deaths that come from, to birds in particular from fossil fuel generation is probably much greater. So, right. We can't look at this isolated. There's some issues involved, but if we're comparing it to generating power in other ways, those involve deleterious impacts on animals as well. So the idea is to try to improve this technology as much as possible to minimize those impacts.
Yeah, I think that was going to be my comment, was that, we know, I think that when we look at the, wind power, there's obviously been more criticism of it lately because of the impacts to birds and, seeing how many, birds might die per year from it. But I think we also associate just in our heads that is a very direct impact, right? You can see, a bird that's been killed by a wind turbine, and that direct cause and effect, right? Whereas something like fossil fuels, we don't see that direct impact. We don't see, I guess maybe there are some cases, but maybe it's just not as well known. Whereas the indirect, causes of habitat loss and, species, degradation, all this stuff caused by climate change is probably far more damaging than wind power.
We see it when there's an oil spill. We see images of animals covered in oil, and it's terrible and awful. But we can tell ourselves, well, this is when things aren't working right, when this is when there's an accident. But of course, there's all kinds of things that are happening when things are functioning properly that can cause deaths to different species.
Right.
Now, it has to be said that fossil fuels are also involved in creating and fabricating turbines. But the idea is if you have to crunch the numbers there. And once that's done, once it's functioning, it's then creating, using renewable energy in order to create electricity, to create power. Researchers at the National Renewable Energy Laboratory are also establishing an approach to manufacturing wind turbine blades, which would use a thermoplastic resin system. Of course, that's using probably various chemicals and things like that might have some issues, but the idea is that there would be an overall reduction in the energy needed to create and manufacture blades. So people are aware of what's happening here, and part of industry is focused on reducing the energy needed to create this form of energy production. So to continue with some of the challenges here, wind power is variable, so energy storage is needed to make it more reliable, and designing the batteries and these kinds of things that could function that way is an additional challenge that complicates things. Wind farms are not always located near large population centers, so whether they're on or offshore, they're often very far away from population centers. And so as you transmit energy from the point of origin to where people are using it, there is a loss associated with this transmission. So that's another consideration. So developing the transmission lines is one of these big challenges. There seems to be a debate as to whether people who live near them are experiencing health issues or not. What I've seen is that there's a lot of suggestions that it hasn't been the case, but there have been some suggestions that it might be the case. And so that's something we'd want to keep researching, because there's all kinds of issues there, and that would be complicated with equity issues. Is it the very poor that are living near these kinds of things? So we would want to make sure that that's factored into our consideration of this.
Yeah, I imagine well, I mean, again, I don't know exactly, but just as we're talking about the noise that it's making, I think that does have, somebody's completely inundated by noise constantly. That could have some impacts.
Physical and mental health can be impacted that way. So it's not a small issue. And it's something that has to be taken into consideration when we're locating wind farms.
Yep.
We talked about there's some resistance from the fishing industry in the United States in particular, and probably other places as well, with concerns about the impact on fishing grounds and the navigation through offshore wind farms. And then, what I'm mostly talking about here are these large scale things. So, we could revisit this at another time and talk about much smaller scale wind farm, not wind farms, but much smaller scale operations where it's really kind of an individual type of thing and how viable that might be. And in the way that people maybe have solar panels on their home or are powering something that they, if you go camping, you have some solar cells that are powering something you're using. There's all kinds of different applications that wind power might factor into, which we're not really addressing head on here. And then something that I just read about that I mentioned that I don't think has gotten too far are airborne wind turbines. So if you can think of kind of like a kite where something is released into the wind and then pulled back at a time when the wind's not there. So this might allow more flexibility and there might be some possibilities there.
There was one, so that just in talking about small scale wind power, that just sort of jogged a memory kind of. So here in Portland, there's a relatively new building in sort of downtown. I think it's maybe like 10-ish years old at this point, maybe 15 years old. But it has a series of like 6 or 8 sort of wind turbines sitting at the top, and so it's able to generate some of its electricity for I'm assuming its residents or something, maybe it's common power through that. And I think that's a pretty cool aspect of wind energy, is being able to use it in sort of maybe more micro areas, such as, like you said, with solar energy, and especially on top of big buildings where they're already pretty high up. And therefore,
that's right.
Is there additional sort of benefits to that in terms of the amount of wind velocity, versus, all that stuff. Yeah. So
these are all additional considerations that, maybe we come by and look at small scale energy in another episode or something.
Yeah.
Well, let's talk a little bit more about the global geography of these things. And there are 5 countries that I've got here on my list where they're the top 5 countries where wind electricity generation happens. And together they generate, I think, easily more than half the energy worldwide. Do you want to take a guess to what any of these are?
Yeah, I'm gonna guess China's number 1.
China is number 1. Yeah. Kind of far and away. Really? 34% of electricity generated on the planet by wind power happens in China.
Yeah, I guess I would have guessed China just because knowing that they've pretty intentionally sort of driven a lot of renewable energy projects forward in recent years. And so that makes sense that they're also a fairly wealthy country these days. They have that means. I would guess number 2 would be India. Also, just knowing they've done a lot of energy projects, renewable energy projects. Am I right?
India is on the top 5, but it's apparently number 4 on the list.
Number 4. Okay. My number 2 would probably be the United States then.
United States is number 2. So 20% of global electricity generated through wind power happens in the United States. Germany is 3rd with 6%. And then India and Brazil are sort of tied for 4th and 5th with 4%. And this is, again, not the percentage of their own energy that's created, but the percentage of all the energy that's created in the world. What percentage is created in these particular countries.
Interesting. Okay.
And so the United States, as I mentioned, has a lot of onshore facilities. And I think China has a lot of both. European countries and China lead the world in offshore wind electricity generation capacity. And so if we want to talk about where some of the largest wind farms are, I've got a list here for both onshore and offshore. And the largest onshore wind farm is in China. It's the Gansu wind farm. And I think it's far and away the largest. The other thing is that these lists are kind of different because you can measure things in slightly different ways. And then there's a number of things that are coming online soon. For example, there's a very large wind farm that's about to come online in Sweden in the next few years, which would make it the 2nd largest wind farm in the world. The 2nd or 3rd, depending on what list you look at, largest wind farm is in Rajasthan, India. So that sort of squares up with your observation that you heard that a lot of wind power is being generated in India. But also number 2 or 3, depending on how you look, is the Alta Wind Energy Center, which is in Kern County, California, which is about 100 miles north of Los Angeles.
Oh, interesting. So, I mean, obviously I'm from the LA area. I've driven out in all different directions at different times. I didn't know about this one that was apparently the second largest. North of California, the one I'm most associated with is the one that's sort of in the Palm Springs area. As you're hitting sort of that area, you sort of get inundated by just windmills everywhere, which is always kind of a fun aspect of driving out there, especially when I was a kid. It's kind of fun.
And if you're from the Bay Area in California, then the Altamont Pass it's not one of the largest operations, but it's a pretty big operation. It's very visible from the highway, and so it's sort of makes a big visual cue that, oh, there's something different happening here. There's another big one. One of the biggest ones is in India, in Tamil Nadu, India. And then one of the ones that ranks pretty high on the list in the world is the Shepherd Flats facility in Arlington, which is in Eastern Oregon, which came online in 2009. So I was not expecting to see that on the list, but since we are broadcasting from Oregon, I thought I'd mention it.
Yeah, I mean, I was going to mention it at some point, but I had heard that Oregon is also exploring some offshore wind opportunities as well.
It's interesting that most of the offshore, the ones that exist and a lot of the ones that are being explored are off the Atlantic, in the Atlantic Ocean, off of the East Coast. And I think the West Coast has been slower developed. Some of these I'm not exactly sure. And there's probably some good reasons why that I'm not aware of. That's a lack in my research there. It turns out that a lot of the largest wind farms onshore, that the United States does have quite a few of the large ones. But if we want to look at the largest ones that are offshore, a lot of the biggest ones are off the coast of the United Kingdom, off of the UK.
Got to be the one. I know there's that controversy with the one in Scotland. I think Donald Trump owns a hotel or something. I just heard about this inside the news, and like that, it's like obviously sparked a lot of debate back and forth.
Well, something else that I just read about the other day while I was researching this a few days ago was that there seems to be some suspicion that Russian intelligence is sort of chronicling, spying upon the wind generation power that's happening offshore in the UK, and that this has raised all kinds of alarms among certain communities. So for a timely connection there, I think what it was is there are some ships that have armed individuals on them that are claiming to be something else. And so there's some suspicion that this might be going on. So not really clear what's happening there. But a lot of the biggest ones, for the biggest wind farms, I think 7 of the 10 largest ones are in the UK. The Netherlands has a couple. Denmark has a couple as well, that are quite large. China has a bunch, but they're not quite of the magnitude of these ones that we're talking about right now. However, having said that, China has proposed building an offshore facility that would be 30 times the size of the largest offshore farm that currently exists. So there is big plans to make something really big.
Wow.
This seems like it would be a good time to listen to a couple words from our sponsors, whoever they are, and come back and round out this conversation about the global situation and then drill back into the United States.
Geography is these sponsors right now.
And we're back talking about wind power on the Geography is Everything podcast. And we were talking about where some of the biggest facilities are throughout different parts of the world. And now let's talk a little bit about some of the largest wind power companies. And again, these lists are they vary in terms of the rank, depending on whether it's revenue that's being measured, whether it's market share or installed wind capacity. But according to the 2022 Global Wind Turbine Market Report, which is based on both market share and installed wind capacity, the largest of these companies is Vestas Wind Systems, which is based in Aarhus, Denmark. So that is the largest company by that measure. We have Siemens.
Walk by their office here in Portland.
They have an office in Portland. I've gave a presentation there once before. Shout out to all the people of the Portland office
Right.
invested. The second one globally is Siemens Gamesa Renewable Energy, which is a Spanish-German consortium based in Zumedio, which is in Biscay, Spain. We have GE Renewable Energy, an American company, and apparently the renewable energy headquarters is in Paris, France. Pretty interesting arrangement. We have Goldwind, which is a Chinese company headquartered in Beijing, and then Envision Energy, Chinese company headquartered in Shanghai. A couple of the other big ones, and especially if you bring annual revenue into it, are Mitsubishi, headquartered in Tokyo, Japan, RWE Renewable in Chicago, Next Era Energy in Juno Beach, Florida, Avangrid, which is in Orange, Connecticut. A shout out to my Connecticut peeps. And then there's another one, Suzlon, which is in India. So there's some pretty big companies kind of spread out a little bit throughout the globe. And so we can see that this is kind of a global movement in some ways.
Yeah. Yeah. The globalization of energy is definitely
That's
on
right.
full force here.
And I think you also identified that, there has to be a certain level of affluence for a place to be able to invest a lot at this scale. If we were looking at other scales, some other places in the world might pop up as having a lot going on. But at this larger scale, these are the places that have this prominence. But let's talk about where wind energy is produced in the United States. Get a little bit more specific here. Wind energy resources vary hourly and seasonally throughout the United States like they do in other places. And so according to the U.S. Energy Information Administration, good places for wind turbines are where the annual wind speed is at least 9 miles per hour. For the smaller turbines and 13 miles per hour for utility scale turbines. Favorable sites include tops of smooth rounded hills, open plains and water, mountain gaps that funnel intensify wind. So both of those we mentioned in California fit that particular category. Wind speeds generally increase with increasing elevation above the Earth's surface. So being at a higher elevation is usually seen as advantageous. So large wind turbines are placed on towers, and that's the reason they place on these towers, 500 to 900 feet tall, as we talked about earlier, to capture the wind that blows at that level.
And this all tracks with, I think, again, like going back to what I was originally saying about the Great Plains states, right? They're flat. There's a lot of open space. They're also elevation of those states is typically higher than most people realize.
That's right.
Because it's on the other side of the Rocky Mountains, so the elevation's pretty high up. So I think this all makes sense. The one that sort of surprised me was and I just didn't think about it, was that the mountain gaps that sort of funnel wind through.
That's right.
Like whoever thought about that was genius.
That was bright. That was a good day on the job right there when I figured that one out.
Yeah.
I'm going to ask you about the top states where wind electricity is generated, but you've already kind of honed in on it. So you did an episode on your YouTube channel about this corridor in the middle of the country where there's actually very little population, like 2% of the population or something.
America's empty belt.
This is where a lot of wind power is also generated. So if I'm going to ask you, where is the most wind electricity generation in the United States, you're going to say what?
I guess I would say, well, because I think I would say Texas.
Texas is
such a large
state. Number one.
Number one?
It's definitely number one. That's right. By a long shot, by 2.5, maybe 2.7 times as much as the state that generates the second most kilowatt hours by wind, which is Iowa.
Iowa. I was going to guess Kansas.
Kansas is fourth. So it goes Texas, Iowa, Oklahoma, Kansas, and Illinois. And those 5 states produced approximately 50% of total U.S. wind electricity generation in 2022.
It's funny because these states also line up very well with another episode I did on Tornado Alley.
Yeah, well, that makes sense, right? So it's all adding up, right? Why there's maybe not a lot of people there, but there's a lot of wind turbines.
But yeah.
We've been throwing around kilowatt, megawatt, just to define these really quickly. A kilowatt hour is a measure of electrical energy equivalent to power consumption of 1,000 watts in an hour. So a megawatt is a unit of power equal to 1 million watts. It's the amount of electricity approximately that would be used by, and this is tough because homes use different amounts of energy, but in the United States, 330 homes for an hour. That's a megawatt. And then a gigawatt is a unit of electric power equal to 1 billion watts. So that's a large, I don't think we're really talking about that as much.
I think we did in our nuclear episode.
In the nuclear episode, but we're talking a lot more about megawatts here. There are 2 windshore energy projects in the United States. You referenced one of them, which is the Block Island wind farm off of the coast of Rhode Island, which is, kind of near Cape Cod, sort of relatively speaking. And that generates 30 megawatts. So we're talking the megawatt range here. We have the Coastal Virginia offshore wind pilot project. And then other offshore wind projects are currently being developed off the coasts of Maryland, Massachusetts, New Jersey, Rhode Island, and Virginia. And then one in the Ohio state waters of Lake Erie as well. So,
interesting. I was going to ask about the Great Lakes because I feel like they would also be pretty amenable, maybe even more so because, again, I don't know exactly, but I guess I would assume the Great Lakes, the water would be more amenable to building things into because it's probably calmer than the ocean, less acidic.
Although if you've heard the song, The Wreck of the Edmund Fitzgerald, you know that the Great Lakes aren't always that forgiving, but absolutely compared to the ocean, you would think might be some more predictability or stability there. So it'd be interesting to see what happens with that particular installation. And there may be other places in the world where the offshore, I think most of it is in oceans, but there aren't tons of lakes on the planet like the Great Lakes. So maybe that's a unique opportunity. Something I was thinking about that I wanted to raise now, and we're getting close to the end of the episode here is, what is the lifespan of a wind turbine and what happens to these old wind turbines when they have to be replaced? And it turns out that fiberglass wind turbine blades last about 20 years. And I think that we can expect that will be probably increased over time as we,
longer than I expected.
Longer. Yeah. So 20 years, it's a good clip.
Yeah.
At the moment, most wind turbine blades can't be recycled. Now, I think that's changing. And I think in the EU in particular, they've pioneered the kind of thing where they were able to recycle some of these. So what happens is that these blades are cut into sections because they're so huge for transportation. So they're usually cut in thirds and put on the back of huge tractor trailers, semis, however you want to say it. I'm hearkening back to our regional dialect episode by saying that. So these large trucks are bringing them around, and tens of thousands of these blades are due to be dismantled because that's the age in which we've sort of gotten these things up online. So there's a lot of replacements happening. I saw some photographs of some place out in the Western United States where they're digging in a huge hole in the ground and they're just stacking these things there. So these are being buried in the ground, and whether that will change in the future, that sort of takes a little bit of the shine off of the sort of environmental energy side of things. Again, probably nothing compared to what's happening with fossil fuels, but something that we need to mention. The EU apparently are burning some of the blades, but then that emits some pollutants, so you don't have to store it. But then there's some issues with that. So I'm not sure they've. It's certainly cleaner to bury and dispose of equipment used in wind energy than in oil energy. And there's also apparently a company that's trying to develop a method to break down blades into pellets that can then be used in flooring and walls and this kinds of thing. So there's some efforts to try to make this even more sustainable, a bit more sustainable. So now's the point in the episode where we can, I think, round things up and come together with some concluding thoughts here. And we mentioned earlier that combining wind and solar power together may be a really effective way to go. And it turns out that, seasonally, for example, solar energy peaks in the summer, and a lot of places tend to have higher winds in the winter. There's things on shorter scales that are conducive to this complementing of wind and solar power. So it would be interesting to see if these things can develop in tandem with one another. We mentioned that the U.S. state with the highest generation of wind power is Texas, but if you add solar power, it's still Texas.
Oh, really? Well, that doesn't surprise me. Texas,
right?
Feels like
and that's twice as much as California, which is probably the state that maybe people were thinking of as, there's a lot of innovation happening there, but Texas is where a lot of this is happening. A lot of it based on the fact that the environment is very conducive to these technologies functioning.
That's what I was going to say. I mean, if I look at them in terms of, whatever politics, then I would say, yeah, California would seem to make more sense. Obviously, renewable energy is also a lot of capital there that goes into things like technology. But if I look at both states from a physical geography sense, then absolutely, Texas makes more sense. I mean, not that California is not a sunny or windy state. I'm sure it is, but there's also a lot more mountains. There's a lot more environmental factors that I feel like just maybe complicate things in a way that, Texas does have physical geography to it. I'm not saying Texas is totally flat, but certainly maybe a little bit more amenable to this kind of
energy. More amenable, more conducive to this kind of power generation. The other thing I was reading about is that wind power might also pair really well with hydroelectric projects as well. So it's interesting to think about alternative and renewable energy sources, not in tandem, not singular, but in tandem with another one. That these twinning of different technologies might be a really good way forward.
Yeah, and I think on that note as well, we got to do something on dams at some point.
For sure, right?
It's such a complicated subject.
It's riddled with all kinds of complications. There's some big benefits, but there have been massive drawbacks associated with dam creation as well. So that's a little foreshadowing, a little tease for the future there. And having said that, I think we're going to wrap it up by telling the listeners who we are. Geoff?
All right. Yes, this has been a really fun episode, Hunter. My name is Geoff Gibson. You probably know me from my YouTube channel, Geography by Geoff, but of course, I'm also the co-host of this wonderful podcast. You can find me on YouTube. You can also find this podcast and both of us on our Substack, which is geographyiseverything.substack.com. And we would really love to see you there. So head on over there, subscribe. You can listen to this podcast right on that Substack if you want to listen to your podcast that way. But there's also additional content as well. Hunter?
I'm Hunter Shobi. You probably know me as the co-host of this podcast, but in other aspects of my life, I'm also professor of geography at Portland State University and co-author of 2 cultural atlases, Portland is a Cultural Atlas and Upper Left Cities, a cultural atlas of San Francisco, Portland, and Seattle, co-authored by David Banis. And with that, we will see you in the future, or you will hear us in the future.